Hello, welcome back to Cracking the Cryptic. Now, I suppose there are a few reasons not to do the puzzle that we've got on the screen, such as the length of the rule set that I will need to go through, and you will need to understand if you want to solve it, and also the fact that you will have to be able to distinguish these colours. But those are not good enough. It looks fascinating and I want to have a go. The puzzle's by Soter. I think it's a debut, although that name rings a bell, maybe because I'm thinking of Sotek, who we've done a few puzzles by. But I think this is a debut. The puzzle is called Rupees, and a good 10 seconds of research suggests to me that there are, or have been, various hexagonal coins in India. And I think that's what that's based on. But it's a brilliant image. I really like this, and I want to have a go at the puzzle, so I'm going to do it today. And you can try it on the link under the video. I will explain when I do the rules which line is which in case you cannot distinguish the colours. So tune in for that. That'll be in a minute or two when I've told you about Caroline's Halloween Adventure on Patreon. That's our current monthly reward. Everybody is finding it easier than the puzzles in last month's monthly reward. So October's a good month to dip your toe into the Patreon waters and have a go at a Patreon reward. Japanese sums puzzles. And once you get used to the flow of them, even if you haven't done them before, you will find that you can do Japanese sums and you will generate a number of images from the puzzles. It's great stuff by the PBN Institute. We've also, of course, got crossword and connections videos there on Patreon. And we've got all of our apps on another link under the video. You can find your way to all of our apps, which do feature Thermo Sudoku, Domino Sudoku and Line Sudoku, all relevant to today's puzzle. But all of the apps are brilliant. Check them out, along with Sven's Sudoku Pad and our merchandise. However, let's go to the rules now. So, the rules are that normal Sudoku rules apply. So that's putting 1 to 9 in every row, column and 3 by 3 box. Now, digits along a green line, that's this one, differ by at least 5. That's a German whisper rule. Digits along an orange line, that's here below it, differ by at least 4. A magenta line, that's this one, you could call it pink or purple. It contains a set of consecutive digits, but in any order. What else have we got? We've got a grey thermometer on which digits increase from the bulb, the normal thermometer rule. Box borders divide a blue line, the only one not wholly in one box, of course. Oh no, it's not. There's a peach one as well. But box borders divide a blue line into sums of equal value. So those two cells sum equals the sum of those 4. Right, now we have the entropic and modulo lines. Every 3 digits along a peach line, such as those 3, include one number each from the sets 1, 2, 3, 4, 5, 6, and 7, 8, 9. So if you slice your keyboard vertically, every 3 numbers along this line has to have one of each. Along the cyan line, we've got modulo. So every 3 numbers has to have one from 147, one from 258, and one from 369. So slice your keypad vertically for that one. Then we've got black dots. Digits separated by a black dot have a 1 to 2 ratio, so one is half the other. Digits separated by a white dot have a difference of 1, so they're consecutive. And that's it. Those are the rules. So we're going green, cyan, magenta, orange, grey thermo, blue and peach in order. And I love the idea that they're all so perfectly using the same shape and very much the same cells in boxes 2, 3, 4, 5, 6. Anyway, give it a try on the first link under the video. Don't know how this plays yet. I'm going to start now. Let's get cracking. And I'm going to get cracking with the succession of black dots in row 5. There are only 6 digits out of the Sudoku digits that can go on these black dots because of the 1 to 2 ratio issue. And they are 1, 2, 3, 4, 6 and 8. So the other digits are 5, 7 and 9. And we immediately know which one is on the thermo. That can't be 7 or 9 because you couldn't complete the end of the thermo. So that's a 5. In fact, then you can complete the end of the thermo. 6, 7, 8, 9. That saves me the trouble of explaining how I knew that 1, 2 was one of the pairs in this row and 4, 8 another one, because I get 8 there and I can write 4 in. So there's a start. The other digits in box 6 are 1, 2 and 3. The thermo doesn't tell us which way around they go. Now, this cell can't be a 1. On this Renban, we are going to have a set of the digits, a set of consecutive digits. They include either a 7 or a 9. If they include a 9, we know that the set of digits is 987,654. If they include a 7, they could go down as far as 2, but they can't go to 1. So that digit is now 2, 3, or 6. But that didn't actually reveal what was going on here. So let's try orange. Yes, okay, here's a point about Dutch whispers. What I would have told you, what I will be telling you later about German whispers, with a difference of 5, is they can't have a 5 on. They must alternate between higher than 5 and lower than 5 digits. And actually, in this one, you can't place 4 or 6 on it either, because every cell has 2 neighbours that see each other within the box. And 4 and 6 only have 1 possible neighbour. Now, we have a lot more freedom with a Dutch whisper with a difference of 4. However, if we weren't to alternate between high and low, the only way you can avoid that is by having a 5 on the line. Now I can tell you there's no 5 on this line, and I can tell you that because that would break the alternation pattern, and this is a 6-cell loop. Now why is that a problem? If there was a 5 on the line, it could come between 9 and 1. They're the only digits 5 can border. So imagine there was a 5 here with 9 there and 1 there. Now you can't alternate between high and low from those positions between 9 and 1 on the rest of the line. You'd be going high here, low here, and high here next to 9, and that would break. So there is no 5 on the line. 5 must be in one of those cells. And therefore we are alternating between high and low. So let's write in 1, 2, 3 or 4 there. 8 or 9 here, that sees 6 or 7. 1, 2 or 3 here, that sees the 4. This one is high, 6, 7, 8, not 9, 6, 7 or 8. That is 1, 2, 3 or 4. And I haven't really learnt much else from that, but I've pencil marked a lot of cells. That is 1, 2 or 3. This can't be a 3 now. It is 1, 2 or 6 on the black dot. Okay, now something I learnt while I was lecturing about the green line here is that 4 and 6 can't appear on this line any more than 5. So 4, 5, 6 must be a triple off the line up here. This must be low because that is 1, 2, 3 or 4. This can't be 4, 5 or 6. So this is 1, 2 or 3. And now we can fill in around alternating cells the 1, 2, 3 triple, and around the other alternating cells the 7, 8, 9 triple. Is that giving me anything in this column? No. How about any other columns? Not really. That's a bit surprising. I don't quite know what to do next. Okay. How about, what is this? This is a modulo line. So we've got, well, I don't know how to use that yet. Bum. 5, 4, 5 and 6 must appear on this line because of its length. But the digits, the neighbouring digits don't have any relationship with each other particularly. Tricky. Okay, I don't quite, oh, we've got a 4 here, given 4. Right, that rules 4 out of a couple of cells. Now I know that the even digit on this white dot, it must have one, is a 2. So that can't be 2, so this can't be 1. And we're getting things narrowed down a bit in this column now. For some reason, it's harder to see the black digits when you're used to focusing on the blue ones after a while. Well, that's what I find. It's a pathetic excuse. It's all I've got. Oh, it's interesting. So whichever one of these up here is a 3 is surrounded by 8 and 9. That is 8 or 9 as well. Where are we going with this? I'm going to have to look at these other boxes because box 6 was handy for a start, but I've got a bit bogged down after that, as you can see. I suppose I could fill in that that is not a 2, so that's 1, 3 or 6. That's 2 or 3, but this could be 4. No, this can't be 4 because that would be a 9, 8 pair. They're the only digits that can be next to 4, and that would break. Right, so we've got a 1, 2, 3 triple. Now this center cell must be 6. Okay, I didn't have to go to the alternating lines of cyan and peach. That 6 makes that a 3. Now I can fill in 2 and 1 here. That 3 comes out of those cells. 6 comes out of that one. This is still a 7, 8, 9 triple, but it's a bit. These are now a 4, 5 pair. 6 is looking at that digit now, so that's a 5. Central column? No, one of those is low and one is high. The low one is 1 or 3, but the high one could be anything. It didn't get me out of my little problem, did it? So, okay, this digit can't be 6 or 4, but it's on a black dot. 1, 2, 3 or 8. That is going to be next to 2 or 4 or 6, and that's all. This can't be an 8 by Sudoku. It could be a 1 actually, so that wasn't quite all. Apologies. Now, this one is the line that is alternating between... Oh, right. Every 3 cells on this line has a digit from 147, one from 258, and one from 369. Yes, okay. So what that means is that since those, for instance, if they were 1 from 258 and 1 from 369, then to make up the set of 3, this would be from 147. But to make up this set of 3, this would be from 147. So we're always, every 3 cells, we're going to alternate into the same group of digits. And that means that these two are from the same group of digits. And they see a 6 and a 9. So they can't be from the 369 section. They're either from 258 or they are 1 and 7. So whatever this is, but it has representatives from, well, oh, do I know this couldn't be a 4, 6? No, it's not 4, 6 pair. Do I know this couldn't be 2, 8? Almost. Yeah, this couldn't be a 2, 8 pair because we've had 5 from the group. So if this was from 258, they would be 2 and 8. Oh no, well, that would be a 2. That would be an 8. Now these would have to be the same. They would be 1 and 7. And that 2 wouldn't have a companion here on the black dot. That's a bit complicated, but it is true. These can't be from 258. So they're either from 147 or from 369. Oh, now I've been led into fully pencil marking something that I didn't want to have to. Okay, maybe we can learn from that experience down here. Oh, maybe we can't. No, let's... These must be 1 each of the digits from... That's weird. It's true, though. They must be 1 each of the 147, 258, 369 set, because 2 each are getting used up on the green line in this box. And that relationship isn't going to prevail down here where this does something else. Right, I'm sorry. These digits... do we get unstuck here? Haven't thought about the blue line at all, but I don't think I've got useful thoughts for that at the moment. Okay, come on. These two are from the same set of either, or they can't be low because that would be too many 1, 2, 3s in the column. If they were from the 4, 5, 6 set, they are 4 and 6, but otherwise they're from 7, 8, 9. The set that is not represented there is 1, 2, 3. So one of these must be from 1, 2, 3. And one of these must be from 1, 2, 3. And that's quite interesting. I've just noticed that 3 is looking at that digit. But that is 1 or 2, and the other one from 1 or 2 goes here. Now, has a triple been used up? No. How about here? 6 and 9, but we don't know that that's a 3. Ah, there's something funky going on here. I feel like I'm nearly getting this now. Oh, 6 has to be on this line. There's another thought. So it's on one of those cells. I don't know. This is a Dutch whisper. That doesn't fix 7, 8 or 9. No, I mean, whatever we fill in now is going to obey that. This is the one where we're not necessarily going to obey it. One of those two is a 3, so that can't be 7 anymore. That is 8 or 9. This does limit this a bit. It can only have one digit from 9, 8, 7. And one from 4, 6, 5. That's nothing to do with entropy. That's just because those have been used up ahead. So 9 and 6 is the maximum, 15. So that's the maximum for this group of cells, 15. Doesn't quite mean they have to have a 1 on, although it's getting closer. Right, I'm a bit stuck here, Soter. What am I meant to do? There's a 2 there, 5, 6, 4, 2. 1, 2, 3 triple. That is a 1, 2, 3 triple, isn't it? So 3 is in one of those cells and not there. I haven't seen that. That's now a 1, 2 pair. These are from 3, 4, 5, 8, 9. 2 is on the line. There. That's vital, and I haven't clocked it. So that is now not able to be 9. That's a 7. Ah, this is going to do tons and tons of work. So 9 and 8 are not on the line either. It is 2, 3, 4, 5, 6, 7. Anyway, this 9 completes the high triple in box 5. 8, 7, 5. That can't be 7. That can't be 8. This can't be 9. So the big digits up here are done. 7 has to be surrounded by 1 and 2, so that's the 3. Now, down this column, oops, that went wrong. We've got a 3 and an 8 still to go in the bottom box. 3, 8, 9. 9 has gone. The highest this pair can be now is 7, 6 equals 13. Now there does have to be a 1 on this 4-cell line in one of those. And this line has to add up to an absolute minimum of 10. So if we didn't use the 7 here, we couldn't do it because we could only have one number from 6, 5 and 4. If we didn't use the 7, the most we could do is 6 and 3. No, 6 and 2 even. Nowhere near enough. So the 7 is definitely on that line. Along with what? Not 4, 8, 3, 9. So it could be 7 and 6. Otherwise, oh, it could be 7 and 5. Otherwise, it's 7 and 2 or 7 and 1. That's not enough to sustain this side. So it's either 7 and 6 or 7 and 5. This adds up to 12 or 13. Does it have to have a 2 in it? No, not if it was 1, 3, 4, 5. 3, 8, 4, 7. Okay, now, there's a 3, 4, 5 triple, so that's a 9. 8 has to be off the line as well. We've worked that out, so that's there. This pair are from 3, 4, 5, 6, and they definitely include a 6. But 3 is over there somewhere, so they don't include a 3. Okay, good. Now, where are we next? Can we get onto this line? Maybe we know something about this. This is the, I have to keep checking, this is the peach line, which is, oh, if it had a high digit, it definitely has a low digit on, doesn't it? Because these two don't. So there's a 1 or a 2 on here. That means this is 5, 6, or 9. And then the other digit could be middly, 5 or 6. The other one that's not there. Or it could be 9. There's a low digit here. Oh, well, this was so obvious, but it took me a while to spot it. Now, 3 has gone out of those cells, so this can't be 6 on the black dot anymore. That is 1 or 4, and I think this can't be 1 anymore. This is now 2 or 8. And that is from the 2, 5, 8 set of digits. Is that interesting? Yeah, we said each of these are one of them is from 1, 4, 7, one is from 2, 5, 8, and one is from 3, 6, 9. Well, that's the 2, 5, 8 one. This is from 1 or 4. So that has to be from 1, 4, or 7, and it can't be 7 anymore. So that is now a 1, 4 pair. I can take 1 off those, and now these can't be from 1, 4, 7 either, and they are from 2, 5, 8, and that is a triple. 6, 4, 9. These digits are 1, 3, 7, which is 1 low and 1 high down here. So 7 is definitely included in those cells, not here. And now I've got an X-wing on 7s. Oh, this was very unexpected in rows 7 and 8. So 7s are used up for boxes 8 and 9. And the 7 in box, oh, look at that. The 7 in box 7 goes on this line. And now its minimum is 13. That's the maximum here. There is the key breakthrough. Brilliant. This is really good, Soter. So this is 1, 2, 3, 7 now with, let's get rid of all that. We know 7's in one of those cells. We've just worked that out. 1's in one of those. 2 is in one of those, and 3 is somewhere on the line. 1, 2, 3, 7. So we now know these are low and high. So these are low and high in some order, including 9 and 1 or 2. That is not 9. That's one of the middly ones, but it's not 6, so it's 5. That's 4, that's 6. That gets us 4 and 5. This is 1 or 2. This is lovely. 1, 3, 7 triple. We can take, oh, we now know we've had low and high here, so these two are middly. 4 and 6 are necessary. They see that cell, that's a 1. That's a 4, that's now 8 on the black dot. 2, 5 pair there. These have to be from the 3, 6, 9 set. 3, 9, or 6, 3. 7 in the box is definitely there. This is from the 3, 6, 9 set as well. So that is 6 in the corner because of that 3, 9 pair that I just created. Now in this column, 1 there says that's a 2. That's going to do quite a lot of stuff elsewhere. Yeah, 3 here on the beginning of the thermo. That makes that 9 and 3. Loads going on. This is a 2, 5, 9 triple. That's an 8 to finish the box. This is a 2, 6, 9 triple. Probably not very helpful in unmarked box 1. What a lovely puzzle. 1, 2, 3, 7 is a quad there. That's a good spot. So that's 9 and that's 8. And that's 5. Wow. That unlocks quite a few things, doesn't it? So that's 3. Now we can do some of this blue line. Not actually as much as I expected. Oh, that's become a 7. So that's not 7. We've got a 1, 3 pair here and a 1, 2 pair. 3 X-wing, no, but maybe these two, yes, they're obviously, oh look, it's a 1, 2, 3 triple. So that's not 2. So I can put in 2 and 9. Use the 1, 2, 3 triple again and say that these are from 5, 6, 7. 2, 3, 7 are there though, so they are a 5, 6 pair. That's 7, that's 6. That's now 4 and 6 resolved. That's a 4, that's where it goes in the box, in the row I mean, 8 and 9 there. Now, that's not 9, so 9 is done in row 2. 8, 2, 9, 6, 3. There's got to be a 1 in this row, and I've got to put it there. Absolute knowledge bomb. That's become a 5, that's a 2. This is a 4, 7 pair. That's an 8, and 3 and 5 still to go. We could get a 3 in the corner. 2, 3, 7. That's not... Oh, these don't have a 5 in. They're 3 and 4. So these are 5 and 6. And that's a 5, 6 pair now. And we do get 3 in the corner. That's 3 in the corner. That's 3 in the spotlight, proving its position. And we are largely finishing off the puzzle, I think, now. Although now what? Something must disambiguate the rest of this. 4, 7, 3, 4. Something. Oh no, that's a 2. There we go. That's quite helpful. I mean, I could have got there from this in the column, but anyway, I hadn't finished off box 5 as I thought I had, and that is now teaching me how to do the rest of the puzzle. Thank goodness. 4, 3, 4, 7. Lovely, lovely collection of rupees. You broke a lot of pottery and have received 7 rupees. Congratulations. Is that from a particular game that I should know about, I wonder? I don't know. But thank you, Soter. That was good fun. Clever puzzle. That was really good, actually. That was put together beautifully. So definitely worth doing, despite a longish rule set and some colour identification necessity. Thank you for watching. Hope to see you again soon on the channel. Bye for now.